Hello everyone, welcome back to my new video. So the question today we are going to solve is tuple with same product. I'll make this question very easy for you. The approach that I'll explain you'll just think like this is the very easy question, not a medium level. Okay, so before moving forward, let's say about the what is today's motivation to move in the day. So, discipline is the key to unlocking your true potential. I think this is very clear that if we are disciplined, then we can achieve whatever thing that we want to achieve. Okay, so let's go to the question. Let's say we have given an array nums of distinct positive integers. Okay, return the number of tuples A, B, C, D such that here we need tuple of length 4. Understood? Such that A into B equal to C into D. Okay, where A, B, C, D are elements of nums. Nums means the part of the array, and all the four are different. Okay, understood? So what we have to check here, we have to check this thing. If A into B equal to C into D, if is it so, then we have to return that four element. But what we have to return, we have to return the number of tuples, not the element but actually the number. Okay, so let me explain you the example, then it will be very clear for you to move in the question. So we have 2 3 4 6 0 1 2 3. So what we have to do, we have to do A into B equal to C into D such that A not equal to B, not equal to C, not equal to D. Okay, so one thing you have to focus from the question itself is that all the numbers of this array are distinct. Understood? So 2 is, as we can see, that 2 is not equal to 3, not equal to 4, not equal to 6. Okay, so we have to find that, we have to achieve this condition. Okay, and what we have to do when we are achieving this, then we have to check that how many different way the same thing can be possible. Means, let's say if here we are checking this for this condition, then what we have found here, we have found 2 into 6 equal to 3 into 4. So the first case that we got here, or the first tuple we got here, is 2 6 3 4. Okay, this is our one result. Now second result can be 2 into 6 and 4 into 3. Yeah, that's also true. So 2 6 4 3, easy. Now the third can be 6 2 3 4. Okay, now as you can see here, 6 2 3 4. Now third is, now we are swapping these two. Now we are putting this part forward, 2 6. So if you see this, the thing is here, the one thing to note here is that here we got only, okay, let me, here if you noticed, here we got only one combination of ABCD, one combination of ABCD, but because of the different permutations of ABCD for the single value of AB, or for the single tuple, after doing the permutations we got 8 result. As you can see here, from 4 elements we got A, B, C, D, the four different value, and because of the different combinations of the permutation, not a combination but the permutation, we got 8 result. Yeah, understood. Now let's check for this example. Here we have given 1 2 4 5 10. Okay, Now 0, 1, 2, 3, 4. The same thing will happen here. The first combination we are getting to satisfy this condition is 1, 10, 2, 5. Now we know that 1 into 10 equal to 2 into 5. अंडरस्टूड भाई ये सब इजी है, इजी, कुछ इसमें वो है नहीं। अगर तुम्हें यहाँ तक पसंद आया तो लाइक ठोक दो महाकाल के लिए। ठीक है, तो ये है 1, 10, 2, 5। अंडरस्टूड। नाउ दिस इज अवर वन टपल। Understood. Now we are finding all the permutation. So what are the remaining permutation? Say 110 here, 110 as it is, but we are just swapping 2 5. Then we are swapping this 2, but the 2 5 will be there. And then we are keeping this thing as it is. But yeah, so for this also 8 combinations, 8 permutations will be there. Now we have another possibility of 2, 10, 4, 5, and here also satisfying the condition 2 into 10, 4 into 5. So here we are also getting 8 possibilities. So that's why our answer is 16. Understood? Very easy. Now let me tell you the approach, the solution, what we have to do here. So what we are doing here, we have to check that the multiplication of 2 should be, any two elements should be equal to any other two element. Yeah, that was our condition, right? A into B equal to C into D. So I am currently telling you the direct optimal approach, because brute force you are able to get in your mind and easily write the code for it. But I will give you the optimal approach. Okay. So what we found here, we found that the multiplication of two element should be equal to the multiplication of any two element. Understood? So for this case, which is our 2 3 4 6, 2 3 4 6, here we know that the multiplication of any two element means 2 into 6 should be equal to the other two elements, which is 3 into 4. If this is the case, then this is our one possible answer. And at the end, what we are doing, we are just multiplying by 8. So total case possible are 8. Understood? So the same thing we are checking here. So my approach is the same. Like if we want to check that the multiplication of these two is already there, and how I, okay, let me put it in another way. If I want to check that this multiplication of any two element is the same as the multiplication of any other two element, okay, so I'll have to track the multiplication of two element, and when any other two elements multiplication will be same as the previous two elements multiplication, it means that A into B equal to C into D is satisfied. So which data structure comes to your mind for this thing? I think hash map. Many of you got that. Why hash map? Because in hash map, I'll store the count for the multiplication part. If A into B means, if let's say 12 comes first time, then I'll store the count as 1. Now again 12 come, then I'll check that if 12 is in the map. Yeah, if it's in the map, it means that there is already once come 12. Okay, once came. So that was our one tuple, where before multiplication and after multiplication I got the same thing. Means before this for any AB and after this any CD. Understood? The same thing we will do here. Let me write the approach. Okay, if you find any difficulty, then do let me know in the comment section, because I want to interact with you people. I want to improve my approach. I want to improve that how I can explain you in better way. Understood? Okay, so what I can do here is, first I'll traversing, I'll have to find the two elements multiplication should be equal to any previously computed multiplication which are stored in the map. So for that I require one map. Okay, map for storing multiplication. Now for traversing I require one first Okay, let me write as first, not 1. Let me write as first for loop. Okay, for outer index I, then second for loop for inner index j. Now what I'll do, I'll have to do the any random 2 multiplication. Okay, and what I'll do, I'll store that multiplication. Before that, I'll check that if, let's say this is our nums array, so nums of I into nums of j, which is the multiplication, is already okay in map. If it's already there in the map, then I'll increase the count. Okay, or I'll just make the count to what, to the how many times it will be, it came, means how many distinct time it came, and or we can say that how many uh time it came in a pair. So let's say this is my map of this result. Understood? And I'll store this result into the count. So what I'll have to do, map of this result plus plus. Okay, and at the end I have count, so I'll just do 8 into count, because for each possibility of the tuple we have 8 permutations are there. Understood? So what we have to, let me again, we require a map to see that if the repetition of that same multiplication is again came. Okay, so for that we require map. Now traversing for the 2 element, we require 2 indexes I and j. Easy. And after that we'll check in the map. Okay, let me directly move to the code part, then it will be easy for you to visualize the same thing. Okay, so what we are doing here, first the initialization of the map, the count to check how many times it came. Now the outer loop, the inner loop. Now finding the product, I'm checking that the product is there in the map. Yeah, if it's there, then increase the count by the number of times the product appeared. Understood? And store the product in the count. At the end, do the count into 8. I think uh, I give you the best explanation for this. So let's analyze the time complexity. So if we are talking about the time complexity, this loop will run in worst case n times. This will loop run in n times, as we are using an ordered map, so all the operations are in the constant time here. So the time complexity is order of n square. Understood? So this was very easy question. Thank you guys.